Lesson one of exploring parallel lines. The big idea here is to identify any relationships you see between the measure of angles formed by intersecting lines, and you have to know the vocabulary. So, as it says right here in your notes, draw two parallel lines and a transversal. I've already done this for you. And measure all the angles. So, a transversal is a line that cuts across another line. And in our picture right here, you'll see the transversal is the diagonal one. So this is our transversal right here, and I'll just call it little t. Now, these two lines, I'll call it L1, L2, they are parallel. And here's the little symbols right here for parallel. If you ever see in future notes or in the textbook, these little arrows, that means parallel. So pause the video right now and measure all the angles. Do it as accurately as you can, but you are going to see certain relationships. Okay, so now that you've measured them all, I'm just going to put in my measurements and see if yours match up, or they should be pretty close. So if they're pretty close, that's good enough. And here's what we would find. And I really hope it's obvious that you might see some relationships. Now, there's a bunch. We're just going to look at a few right now. And the first kind are called supplementary angles. And supplementary angles are angles on a line, also called angles on a line, and they add up to 180 degrees. So using my color coding right here of the ones above, supplementary angles are angles on a line, and there are usually two, but there can be more. Usually two. And they add up to 180 degrees. Always. So here's a quick little picture where we have whatever these two angles, I'll just call them A and B, and A and E, angle A plus angle B are going to equal 180. And if you look at the picture, you see it. Okay, vertically opposite. Vertically opposite are literally as it says, or just opposite. It doesn't have to be vertically opposite. So those are examples of some opposite angles. And opposite angles are just angles across from each other. Angles across from each other. At a place two lines cross. And they are equal. And that's what you should have seen above. So for example, in that idea, if we had this angle, angle A and angle B, well, given that they're opposite, angle A is going to equal angle B. And finally, the last one, which may be the new one for you, corresponding. So let me just erase these quickly. And what we saw is, just for example, relationships like this. So I'm going to highlight a pair of corresponding. That corresponds to that. And corresponding angles, hopefully you see what they are right now, but here's my little definition, but you wrap your head around, you make meaning yourself. Angles that occupy the same relative position. Angles that occupy the same relative position. And I just like to use the word matching. Makes sense in my head. At an intersection where the transversal crosses two other lines. So if I drew you, again, another little picture, this angle here, I'll just call it again angle A again, this angle B, those are corresponding. So they match. They are on the same side of the transversal, and they are above each one of the parallel lines. And when that happens, they are equal. And hopefully that's what you saw. So those are the three ideas for today, and we'll build on them in future videos. So when you flip onto the back page, here are some of the examples of those corresponding angles. And with two parallel lines, there are 4 different pictures that can happen, but they're all this same idea, matching. This side of the transversal above, this side of the transversal above, this side of the transversal below each parallel line, this side below each parallel line. So given that this relationship is always true, what we can go ahead is we can go ahead and answer questions without actually measuring. So here are a couple of simple examples to get us going, but I also want you to think about why you think an angle is whatever measure you think it is. So in this one right here, what we can do is we can use the corresponding idea to notice that angle 35 and angle A are corresponding. They are on the same side of a transversal and above the, or to the left, I guess, if you want to put it this way, in this example, to the left of the parallel lines. So given that they are corresponding, angle A has to equal 35 degrees because it is, and I'll just use a shortcut for because it is a corresponding angle, there will be my shortcut for angles, to 35 degrees. So again, we don't have to measure it, we just use this relationship. Given that we found angle A, we can then go ahead and find angle B. Angle B is equal to 145 degrees because it is supplementary. Remember, supplementary angles add up to 180 degrees. Supplementary angles are angles on a line because it's supplementary to angle A. So in figuring out B, all we did is 35 plus angle B is equal to 180, and we did that little bit of algebra. Next example, if we want to find all of these, there's enough information here, and the numbers are very similar to what we did. So I'm going to go through it really quickly. But the key idea is we want to try, whenever we answer these kind of questions, we want to try to use the given information until we have to use something we may have calculated. So the only thing we know here is this angle right here, but we also know that those two lines are parallel. So given that, we can go ahead and figure out all the other angles. So one piece of information is going to allow us to solve 7 other questions. Sometimes order matters, sometimes doesn't, so I'm just going to go in order. Angle A is going to equal 40 degrees. And the reason, so again, because it is supplementary. So I'm just going to shorten it a little bit. It is supplementary to 140 degrees. So this is the idea of we can actually use the 140. Angle B is equal to 140 degrees because it is opposite to our given angle, 140. Angle C is equal to 40 degrees because, again, it is supplementary to the 140. Now for the rest of, well, almost the rest of these, we might have to use other information, but we can figure out one angle based on what we know right now. We can figure out angle F. Angle F is 140 degrees, and again, because it is corresponding, it matches the positioning is corresponding to that 140 degrees that we know. Every calculation after this, it's going to be based on something we don't actually know. So what I mean by that is angle E. So angle E is 140 degrees because it is opposite angle F. And we know angle F is 140, but we're using it. Angle D is equal to 40 because it is supplementary to angle F. And we know angle F is 140, and we know angles add up to 100. Supplementary angles add up to 180 degrees. But really, we're hoping we did angle F correct. And finally, angle G is equal to 40 because, again, it is supplementary to angle F. Okay. So finally, kind of an understanding question, a thinking question. Instead of saying that these two things are parallel, what we're asking is, are they parallel? And in order to do this, we have to understand one of the properties or two of the properties that we've just seen. There are many ways to go ahead and do this. Here's what I'm going to do. I'm going to try to find this little angle right here, and I'm going to use that angle because I know two things about this angle. I know angle B is supplementary to 40 degrees, but I also know that angle B is corresponding to that. And if I can show that angle B is the same as 140 degrees, then those are corresponding angles, and that's going to answer our question. So I know angle B is equal to 140 degrees, and the reason I know is because it is supplementary to 40 degrees. Now, given angle B is equal to 140 degrees, and the given angle of 140 degrees are corresponding, they're matching, the lines are parallel. So we're kind of going backwards this time. You know, instead of giving you certain information, asking you a question, we're given the opposite information, and you have to go backwards. So that's the end of the things that I want you to know for parallel line stuff right now. We're going to build on that in the next tutorial, in the next video. But I just want to highlight some of the key ideas right now. And this is something you might want to do in the future, even if I don't do them in the video. So our key ideas that I talked about at the very start are know what and how to identify the following. So know what and how to identify supplementary angles. Opposite angles. And finally, corresponding angles. So that's probably the most important thing to be able to do. The other thing that's important is parallel lines have corresponding angles. So simply by crossing two lines, like vertically opposite and supplementary, well, that's not corresponding. And then what we just looked at right there, the very last statement, was if corresponding angles are equal. Then the lines have to be parallel. If you physically tried to do this, they would have to be parallel. So your homework is on the outline, but I'll list it right here. It's page 72 in the textbook, questions 2 to 6.